Welcome to Learn Mathematics. In this video I am going to solve a question. This question is from linear algebra. The question was there in CISR EGC NET December 2011. The question is, let A be the matrix, this matrix, then what is the Jordan canonical form of A. We can see that there are four options. How to tell which option is correct. So let's solve the problem. So to find the Jordan canonical form of a matrix, first we have to find the eigenvalue of the matrix. To find the eigenvalue, let's suppose that lambda is an eigenvalue of the matrix A. Lambda is an eigenvalue of the matrix A. Then we can say that 0 minus lambda, 0 0 minus 4, 1 1 0 minus lambda, 0 0 0 1 0 minus lambda, 0 and 0 0 this is 0 1 0 minus lambda, this one is 5 and this is 0 and this is 1, then this is 1, then this is 0 minus lambda. So this is equals to 0. Since lambda is an eigenvalue of the matrix, so we can write as determinant of A minus lambda I is equals to 0. So this is actually imply that minus lambda into 0 minus lambda into, so this is minus lambda, this is our minus lambda, so minus lambda into this determinant of this, so this is minus lambda into minus lambda, 0 0 1 minus lambda, 5 0 1 minus lambda, plus, so this is plus, this is minus, this is plus and this is minus, so this is minus into minus 4, so we have plus 4 and we are going to ignore this row and this column, so this is determinant of this matrix, so we have 1 minus lambda, 0 0 1 minus lambda, 0 0 1 and this is equals to 0. Now this imply minus lambda into, if we expand this determinant using first element, then first row we have minus lambda into lambda square minus 5 and this is plus 4. Since this is an upper triangular matrix, determinant of this matrix is the product of the diagonal element, which is actually is equals to 1, so this is equals to 0. Now if we multiply, this is lambda into this is minus lambda into lambda square is minus lambda cube and this is 5 lambda plus 4 equals to 0. That imply lambda to the power 4 minus 5 lambda square plus 4 equals to 0. Now we can see for lambda equals to 1, this satisfies this equation, so this can be written as lambda minus 1, lambda minus 1, lambda minus 1, lambda minus 1. Since this polynomial has a highest degree 4, we are writing this lambda minus 1 4 times. Now first is, this is lambda to the power 4, so we can take this is lambda cube, so lambda cube into lambda is lambda to the power 4. Now lambda cube into minus 1 is minus lambda cube, there is no minus lambda cube in this equation, so we will take plus lambda square, so minus lambda cube into plus lambda cube is equals to 0. So here we have minus lambda square, but in this case we have minus 5 lambda square, so we will take minus 4 lambda. So minus 4 lambda into lambda square is lambda is minus 4 lambda square, and we have lambda square minus lambda square here, so we have minus 5 lambda square, and minus we have plus 4 lambda here, so we'll take minus 4 because there is no there is no lambda in this equation, so this is equals to 0. If we take this out, we have lambda into 1, this is lambda cube plus lambda square minus 4 lambda minus 4 equals to 0. So this imply this is lambda minus 1. Now if we take factor out lambda cube from lambda square from lambda cube plus lambda square, and we have lambda plus 1 minus 4 lambda plus 1, and this is equals to 0. So if we factor out lambda plus 1 from this, we have lambda plus 1 into lambda square minus 4. So this implies that eigenvalues of the this implies that lambda equals to 1 minus 1 2 minus 2, and this implies that eigenvalue of the matrices are 1 minus 1 2 minus 2. Since eigenvalue of the matrix are distinct, the canonical form of the matrix is a matrix whose diagonal elements of the eigenvalue of the matrix and all other elements are 0. And so in this case we can say that option 1 is correct.